Hello everybody, thanks for joining me today. In today's video we're going to be talking about the properties of trapeziums. Trapeziums, just the family name for trapezoids. There's three types of trapezoids, so let's just dive right into it. First of all, a trapezoid is a specific type of quadrilateral. Now a quadrilateral is a four-sided polygon. Quad literally means four and lateral means line. So the word quadrilateral literally means four lines. And a trapezium is a special type of quadrilateral that has one pair of parallel sides. So the definition of a trapezoid is a quadrilateral with one pair of parallel sides, and also the mid-segment of a trapezoid is defined to be the average of the sum of the bases. So base 1 plus base 2 divided by 2 is the mid-segment. So that's the definition of a trapezoid. Before we continue and explain the different types of trapezoids, let me also just go over some language that we're going to be using. So the pair of parallel sides are known to be our bases for a trapezoid. So up top we have base 1 and down below we have base 2. And then the pair of sides that are not parallel are the legs. So this is a leg, and this side over here is also a leg. Now typically we see trapezoids in this orientation such that the bases are on the top and the bottom, but that doesn't mean it can't be the other way. So if we have a trapezoid that looks something like this, the left and right hand side would be our bases, base 1 and base 2, and the top and bottom side would be our legs. Okay, so trapezoids can be in either orientation. It doesn't so much matter if the shorter or longer side is defined as base 1 or base 2. It's just important that the sides which are parallel are the bases and the opposing sides are the legs. Okay, moving forward, first up we have our scalene trapezoid. Now the word scalene, you may be familiar with it from our scalene triangle. And what is a scalene triangle? It's simply a triangle where all three of the sides are different in length. None of them are congruent. And so that word, scalene, that word is the same for trapezoid. The two legs in a scalene trapezoid are different in length. Okay, so a standard trapezoid you see is most likely going to be a scalene trapezoid. So some other characteristics of a scalene trapezoid is that, again, it will have a pair of parallel lines. All trapezoids will. And the adjacent short and long base angles are supplementary. So this angle and this angle are supplementary, and this angle and this angle will be supplementary. Remember that supplementary just means that the sum of the angles sum to 180 degrees. Okay? And the reason why the adjacent angles are supplementary is because of our pair of parallel lines. Hopefully you guys remember that if we have a transversal between a set of parallel lines, then we have something called same side interior angles, and same side interior angles are supplementary. They sum to 180 degrees, and so that's why this property appears in trapezoids. Moving forward, we have our isosceles trapezoid. This is the type of trapezoid everyone likes, and that's just because it's pretty, it's congruent. What does isosceles mean whenever it comes to a triangle? Well, an isosceles triangle is whenever two legs are congruent within our triangle. An isosceles trapezoid is the same thing. The legs of the trapezoid are congruent. And because the legs of the trapezoid are congruent, we have some additional properties that are found in isosceles triangles. So not only do they, of course, have a pair of parallel sides, but because the legs are congruent, that gives us a vertical line of symmetry. Here I'm going to move it over, get it a little bit more in the center so it looks a little bit better. There we go. We have a vertical line of symmetry in our isosceles trapezoid. Of course, it will hit at a right angle as the line of symmetry between two parallel lines will be orthogonal or be perpendicular. And a line of symmetry simply means that if you fold the shape over this line, it will be a perfect one-to-one matchup. So what does that mean? That means this top angle and this other top angle will be identical. They will be congruent. They will have the same angle measure. And same for the bottom two angles here. They will also be congruent. Of course, the adjacent short and long base angles are still supplementary. And another property for isosceles trapezoids is that the diagonals from corner to corner will be congruent as well. They will have the same length. Diagonal 1 will be equal to diagonal 2 in length. Lastly, we have our right trapezoid, and you can probably guess what its characteristics are. So a right trapezoid is simply defined by having a pair of right angles. Of course, just like all other trapezoids, it has a pair of parallel lines, and since it's a right trapezoid, it has a pair of right angles, and again, the adjacent short and long base angles are supplementary. Of course, 90 degrees plus 90 degrees is 180 degrees, and this angle and this second angle will also be supplementary. I haven't said it yet, but quadrilaterals have an interior angle measure of 360 degrees, so all quadrilaterals angle sums will sum to 360 degrees. Lastly, let's talk about some common problems you may see with trapezoids. So let's draw a trapezoid. Here, one of the most common problems I see, what if we have a problem such as this? Okay. We're told that this is an isosceles trapezoid, and we're told that this diagonal is equal to 17. And then we're asked to find the length of diagonal 2. Well, it's up to you to recognize that, hey, isosceles triangles, they have the same diagonal lengths. Therefore, diagonal 2 will also be equal to 17. Okay. If you have a problem asking for a diagonal length, 99 times out of 100, it's going to be an isosceles trapezoid, because isosceles trapezoids are the only type of trapezoids that have this property where the diagonals are equal to one another. Okay, what's another type of trapezoid? Here, let's draw a scalene trapezoid. Let's draw a scalene trapezoid. Here we go. Another type of problem would be to find the missing angle measure. What if we are told that this angle here is 110 degrees? And what if we're told that this angle here is 30 degrees? And we are asked to find angle X and angle Y. What can we do here? Well, we need to remember that the adjacent angles are supplementary. So 110 degrees plus Y will sum to 180 degrees. Therefore, Y is equal to 70 degrees. And of course, we can do the same process to solve for X. x plus 30 degrees sums to 180 degrees, and so x must be equal to 150 degrees. Excellent. Excellent, excellent. What's another type of problem? Here, let's delete this. Okay, delete this. Another type of problem could be to find the midpoint. What's the midpoint length? And here, let's say we have some trapezoid. Maybe it's isosceles, maybe it's not. And we want to find the midpoint. And what are we given? Well, let's say that our top length is 20 and our bottom base is 26. Well, remember that the midpoint is defined as the average between our two bases. Our midpoint equals the average of our two bases, so base 1 plus base 2 divided by 2. And so then we can just plug in and solve. Of course, our midpoint is going to be equal to 20 plus 26 divided by 2. The average of 20 and 26 is 23, so our midpoint is equal to a length of 23. Okay. Another problem that you could have is maybe they give you the midpoint and you're looking to solve for one of the missing bases. So let's say they give us that the midpoint is 23 and they give us that this base is 17 and we're asked to solve for x, the missing base. We can still use our midpoint formula in that we have 23 is equal to 17 plus our unknown value divided by 2, and then we just solve algebraically. 2 times 23 is 46. 46 equals 17 plus x. Now we're going to subtract 17 from both sides. Bottom number is bigger, so we borrow. 16 minus 7 is 9. 3 minus 1 is 2. And so 29 equals x. So our bottom base would have a length of 29. So there you go, guys. There's some common questions and properties of your scalene, isosceles, and right trapezoids. Hope you found this video helpful. Hit that subscribe button, leave me a comment down below, and I'll see you in the next video.